So it's 11 local time. We can start the session. My name is Michael Affenzeller. I'm professor for heuristic optimization and machine learning at the University of Applied Sciences Upper Austria, and it will be my pleasure to act as a session chair of this session. The first contribution will be Dmitry Murashov is already with us. He's embedded systems programmer and postgraduate student at the University of Informatics and Automation in St. Petersburg. So please share your screen and start the video, Dmitry.
Let me know in case of sound issues. Just a moment. Can you see that? Can you see the video?
Yes, we can see it.
Well,
hello researchers, I'm glad to greet you here.
Can you hear?
Absolutely.
Yes.
At EMSS 2021. I'm Dmitry Murashov and I'm presenting on behalf of my co-authors. The following is a review of data fusion models and our proposition for an architectural blueprint for implementing a decision-making model based on data fusion. The presentation complies with the following structure. First, I will delineate the key concepts of our research. Then, I will show you some interesting data fusion models. And then, last but not least, I will explain you our approach. While doing this research, we have two objectives in mind. First, we're trying to find interesting data fusion models that describe data fusion of levels 3 and higher. And, which is more important to us since we're trying to find those data fusion models that in themselves provided useful hints on their practical implementation, or maybe had their own practical implementation, which in turn ended in us begin developing our own practical approach for implementing data fusion models, but more on that later. Here are the key concepts of our research. Data fusion and situational awareness. Consider a system that exists in an environment, or maybe an agent. It consumes information from the environment, integrates that information in a broad sense, and this process of integration is called fusion, or data fusion, during which a system creates its own picture of the outer world, which is called situational awareness. The GDL model gives us a reference. It describes the data fusion process in 6 stages, or levels rather. Levels 0 and 1 describe data fusion, 2 and 3 information, 3 through 5 knowledge, and the last one, 6, fusion of intentions, or fusion of pragma. We separate data fusion models on whether or not they imply any mathematical notation, as it was proposed by Steinberg in 1991. The models that do use formal notation are called formal models, and those that don't are called conceptual ones. Formal models. The first one I wanted to list to you is the one created by Gasca and Mapin. This model defines the following entities: agents, states of agents, actions of agents, protocols of agents, facts about system, and language defined upon facts. As you can see, there are other entities, but those I named just now are key entities. So, how do you have our data fusion in a system like that? Simple. We have our initial condition. We have our agents based on a premise, or rather on the notion of a finite state machine. An approach like that. We run a simulation. We analyze their paths. We analyze the information produced during the course of the operation of the system. And as a result, in a unified algebraic framework, we have our data fusion. The next model is more generic. No states, no agents, just clear ontological representations. It defines the following notions: facts, actions defines upon facts, attributes of a domain, Boolean variables, and other entities that define relations relations defined upon those four. This model was designed to serve as an algebraic framework, a unifying algebraic framework where we would integrate our other formal models into. So we have a formal model of formal models. The conceptual model created by use of Enrique authors solved the problem of incorporating an implicit knowledge into the work of the system. This is done through combination of MSC-LES situational awareness model describing the process of gaining situational awareness through three stages: perception, comprehension, and projection, and combination of a SECI model or model of knowledge creation, which describes transfer of knowledge from tacit stage to explicit and vice versa through an iterative loop. The model proposed by Dmitry solved the problem of representation of data and knowledge, which is relevant to a multi-engine system. This approach is practical and ingenious to our sense. It offers us to use three notions. The model proposed by Kutin and Greenberg, which defines relations between agents in social or spatial aspects. The MSC-LES model of situational awareness, which has already been mentioned, and the notion of sensing, visual, audio, or tactile. And all these three models are incorporated in something that is called by the authors of the article 3D SAM, which also has practical implementations which you can find in the article. There is a plethora of reasons why you can call Bowman's DNN model ingenious, but in our sense, the most interesting part of it is that it highlights some aspects of its practical implications, by defining two components of the system. Those are resource management and data fusion. So we have somewhat a clear architectural representation at a high level of how the system that will implement this model will look. But we use this model as a stepping stone to the next system created by Silva. The model created by Silva, called DNDW, is a one iterative step over Bowman's model. It enriches it with another entity called mission planning, which is quite important to our sense, calls and has an entity called decision maker. It may be system, or an agent, or human operator. So here you have a full-fledged architectural representation of a system. The model created by Betiga is a practically oriented model designed to tackle human-produced data such as texts or data gathered from social networks. The key aspect of the model is that it enriches the information processing data flow with the model, with the unit called data information quality assessment. This model is intended to kick off all the information that doesn't meet any particular quality threshold. So we enrich our data fusion process with filtering of some sort. And the last model lays the foundation of our approach. This model is a conceptual representation of a system which describes different entities dealing with different extents of abstraction. Those are data, information, knowledge, and some pregnant data used for decisions. To our sense, the most interesting part of the system is the unit called proactive forecast system. Unlike the previous models, this model is the one that explicitly stipulates use of a dedicated prediction model, which led us to creating a proposal for an architectural implementation of the model, which we will see next. For higher level representation, we offer to use the architectural model of an expert system, because over the years, it has proven itself to be very reliable. Here you can see the detailed representation of the architecture we propose. We define some basic I/O capabilities. We define some communication channel. We define it as a local area network LAN, but actually it can be any communication channel at all. We define the storage, where we store knowledge, data, and the history of observation of the system state. Means of extracting knowledge fusion. Means of observation, the state of the system. And the core of the system is the state assessment and control synthesis unit, which is responsible for data fusion and production of actionable data. But the production of actionable data is performed through incorporating all the previous precedents that are stored in the storage that the system has encountered during its existence. I believe that is the perfect point to stop. I want to express our sincere gratitude to the beautiful people that created all the models we have reviewed here. And also we want to express our gratitude to the audience and to the organization committee of the event. Thank you.
Thanks as well for the presentation, and also again Victoria for the assistance.
Very good.
And I'd like you to raise hands for questions or comments. Okay, I do have a question myself. You mentioned the proactive forecast system, which brought me to the idea to ask you if you have been considering also your approach in dynamic environments when the data changes their behavior for online learning or online fusion. Did you have gain some experience about this as well?
No, I haven't, but I think that's a good idea. Actually, we have designed our architecture the way that this approach can be implemented as well, as I believe. Maybe there are some limitations, but I believe the current configuration can allow that. But yes, thank you. I think that's a great idea, and I think we will implement it the next iteration of our research. Thank you.
Okay, great, thanks. Well, any further questions, then please, in the ideal case, use the raise hand functionality. No, then thanks again, and we move forward to the next presentation. I've already seen Alfredo Benitez with us, and I'd like you to ask sharing the screen and showing your video.
Oh, okay. Well, wait a moment. So, can you see it?
I can see you. Yeah, short introduction. As far to my information, you have been studying industrial engineering and are currently in the master degree program for planning in the engineering department.
Yes, that's correct.
Okay, so please start your video. Okay, again, we seem to have this sound problem.
Oh, you can see the video?
Yeah, I can see it, but I do not have sound.
Okay.
Okay.
Hello. We have sound.
no sound yet. Maybe again we can ask Vittorio for the assistance. It's paper number 105.
Yeah, Michael, of course. I'm sharing my screen.
Oh, thank you.
105. Don't worry. 105, okay.
Hello, we have done this video to present our paper number.
Can you hear?
Yes.
Oh, perfect.
105. The title of our paper is Forecast of the Optimal Activation Function for Stablecoins Using Neural Network. And the authors are Ricardo Torres Mendoza, Genaro Nocedal Sanchez, and myself, Alfredo Enrique Benitez Gasca. As you may know, nowadays the digitalization has spread many different activities of mankind. As an example, in the financial markets, the recently created cryptocurrencies have obtained an enormous influence in the trading activities. Bitcoin, as their main referent, has created a new revolution in the investor's portfolio that some may like and some may hate. And probably the reason for this ambivalent position is because of the lack of support by governments and also for extreme volatility. In order to fulfill this statement, a new type of cryptocurrency was born, the stablecoins, whose main difference from their cryptocurrency brothers relies in the existence of a pegging mechanism that gives them certain stability. There are many articles and simulation developed about Bitcoin and the cryptocurrency market, but when we are speaking about the stablecoins, the number of articles and simulation reduced significantly. That is why we were motivated to develop the present research, because we believe that investors could develop a better portfolio considering the stablecoins, and for that we have employed an artificial neural network. The objectives of our research are as follows. Establish an ANN model that could forecast the main stablecoins. Determine the optimal activation function, which is one of the main parameters of the ANN between sigmoid, hyperbolic tangent, or linear. We use this methodology for our research. We split our study in three main processes: preparation, modeling, verification and validation, and at last, the analysis and forecast. In the preparation stage, at first we define the objectives and also we analyze the different tools to use. We picked Python as our main tool to develop the research. Then we gathered the information from these websites, establishing that we were only going to evaluate the first 10 stablecoins with more capitalization. With the downloaded data, we prepared them and stated our initial date would be March 23, 2020, up to February 16, 2021. That will give us, in most cases, 331 days using only the day closing price. In the modeling, verification, and validation stage, we programmed the model using the library MSC-LES that uses the sequential model from the application program interface called Keras. This process consists of an optimizes the use of stochastic gradient descent using the following equation. The model consists of a 3 hidden layers network with 7, 5, and 3 nodes respectively. We used 100 epochs and a lag of 1 to predict 15 days after February 16. As mentioned before, the activation function used were linear, sigmoid, and hyperbolic tangent. The validation and verification activities took place through this process to verify the logic and the fulfillment of our objectives. In this part, we took the samples of each activation function in a loop of 50 cycles that were compared statistically in the analysis and forecast stage. At last, with the best defined activation function, we developed a 4-day simulation of the best performers. In the following image is presented the results that we obtained with our model. As it is shown, the stablecoin with a lower coefficient of variation was the SUSD stablecoin, with a mean RMSE of 2 cents. The mean of RMSEs remained mostly ascending, and the asymmetry coefficients show a relative asymmetry. Mostly important, in all of our studied stablecoins, the best activation function used was sigmoid, as it could be seen in the next figure. As we defined the best activation function, We use our model with a lag of 1 to 1,000 epochs and an average of 10 cycles to forecast the forthcoming days for the best performers. These stablecoins were USDT, PAX, SUSD, and USDC, obtaining the following results. As it could be seen, the model could be used to forecast the stablecoins market, although in a closer look, it seems that the model cannot follow in all cases the small changes from the stablecoins. As for our conclusions, we demonstrate the possibility of using an ANN model for stablecoins. We proved that the best activation function to be used between sigmoid, hyperbolic tangent, and linear is the sigmoid function in all the stablecoins. The model used in the present research tends to dissociate in the narrow difference in the closing price, suggesting that the model requires further research. But also, more data could be used for an improvement. The present model and research could be used by an investor as a complementary tool to optimize their portfolio. Thanks for watching.
Thanks for sharing your video with us. And I'd like to go back to the meeting room and ask you to ask questions. Kirill Sinelchov, sorry.
Hello, thank you for your presentation. I have actually two small questions. First, what happens if you extend the time longer than 4 days? Like 5, 7, 10 maybe. And the second, do you have some comments about choice of configuration of the network? So number of layers, neurons, and so on.
Yes, thank you. Well, as we have seen in our model, if we expanded the dates to 5, 6, or 15, then the model starts failing, and the RMSE increment increases, and therefore the model fails at or had a worse result. But nevertheless, if the studies, we took only the closing day price. So if you took the intraday, probably the intraday, all the data as a study of Dmitry, he took like 65,000 data information, then that will improve the model. So we have seen also this effect. At the beginning, we only used from March 2020 up to February 2021, and that was 331 days. But at the last part in the forecast of the forthcoming days, we took all the data of the day closing price. So that was roughly in the USDT, like 2,000 registers, and that improved the model. So to answer your question, your first question is, it could be done to expand the dates, but you need more information. Okay, and the other, could you repeat me the second question, please?
Yes, your choice of parameters of the network, layers. Yeah.
Yes, thank you. Sorry. Well, we took from our research and the literature, they recommend in some cases three hidden layers, and that's why we use 3 hidden layers. And in some cases, as we have shown in another studies, they use up to 20 hidden layers. So we, as an exploratory research, we only took 7, 5, and 3. But in this case, it could be let's say, play with the parameters in order to see which one fits better. But at this time, we remain those as a constant and only move the activation function in order to see which one is better. But your question could be done up to 20, because if another studies show or said that if you use more, then you could go to an overlearning process, an overfeeding, and the results would get worse. Okay.
Okay, thank you. Perfect.
Thank you.
Okay, I have an additional question somehow related to the first question, but I would like to ask you for a short answer because otherwise we will be running out of time. I can easily imagine that the forecast horizon can work for even longer periods if there's somehow some clear tendency of the system's behavior. But what's about if we come to turning points of the characteristics? Do you see a chance also, even in a shorter forecast horizon, to identify or to forecast the turning point?
Well, as I understand you, yes, probably there's a chance. This is also an exploratory study, so maybe with a little bit different parameters or more data, then you could see those turning points and see that will help the investors to enter.
Okay, Marina Massey has raised her hand. Marina, please.
Yeah, thank you. Alfredo, did you get some funding, or do you expect to get some funding to support your research?
Well, thank you. No. For a moment, I didn't expect any. I don't expect any funding or something like that. So it was a project, personal project that developed with my tutor for the master. But I don't know if it go further. Thank you very much.
Thank you, Alfredo.
Okay, also thank you from my side, and we move on with the next contribution presented by Marco Vannucci. Yeah, he's already here. He's assistant professor at Scuola Superiore Sant'Anna in Italy, and his research area is about industrial application of artificial intelligence and machine learning. We're looking forward to your video, Marco, please.
Okay, thank you. I'll try to share the screen.
Did you already start the video? Because we do not have sound again.
Oh, sorry.
It's because
I started.
Okay, that's an issue which we
sorry,
already had.
Sorry. There was a switch. There was a switch that I missed.
Okay.
Okay, let me, now it is starting again. Sorry for the inconvenience.
Welcome everybody, my name is Marco Vannucci and I'm assistant professor at the Scuola Superiore Sant'Anna within the ICT Coils Center, a laboratory whose mission is to exploit the most recent artificial intelligence and machine learning techniques within the industrial environment. Today's presentation title is Prediction of Mechanical Properties and Microstructure by using Deep Learning and Advanced Data Preprocessing Techniques. where artificial intelligence techniques are applied to a steel-making problem. Firstly, I will introduce what the input signal is, together with the motivation of this work that focuses on the simulation and the prediction of this signal. Then I will depict how a data-driven model for input signal prediction was developed by using AI and data analysis techniques. Finally, I will discuss the main achievements and the future development of the model. We are in the field of the production of steel coils, starting from the slab on the left of the top picture and going through the steps of this process that leads to the finished coil. The input is a non-destructive test based on magnetic field measurement that is performed on the semi-finished product, in this case, both at the entry and the exit of the pickling line. It returns, as an outcome, a signal corresponding to the measure over the coil length. You can see two exemplar signals on the bottom left of this slide. But why do we are interested in it? It is because this signal, the one at the exit of the pickling line, is strictly correlated to the final product mechanical characteristics, and it is influenced by the condition at the entrance, including material type and entering signal, and the pickling line process parameters. So, what is the motivation of this work? The idea is that if you are able to predict the input signal at the exit of the pickling line in advance, and considering its connection with the mechanical product, operators can take suitable countermeasures to avoid mechanical property downgrades, non-uniformity through the coil length, by operating on the pickling line parameters. Unfortunately, there is no knowledge on which variables influence really the input signal, but we have data collected through the line. In this case, we try to exploit this data by putting up a data-driven model, a neural network, to be able to catch these nonlinear interactions. The available data are those collected on plant during standard production and include all the process variables measured before the exit of the pickling line. So we talk about the O-strip mill parameters, the pickling line parameters, the steel characteristic, and the input entry signal, while the input exit is our target. Our final dataset includes 140 coils and 259 variables, all potentially influencing the input signal. Here is an overall picture of the model development that, due to the characteristic of the problem and of the data, includes a data partition step to create two uniform sets of data, one for the model's tuning and the other for their validation. One step devoted to identification of those variables that are actually related to the input signal within the 259 collected, which is a lot. Then there is the actual model tuning that also includes the optimization of model hyperparameters. Now, let's see more in detail all these steps. The first one is the data partition. But why do we need a uniform data partition approach? You see, the shape of the signal is highly variable, and the number of available coils is limited. With random partition, we risk not to consider some of these families of shapes in one of the two sets, training and validation, which would lead to a biased model because some of them could be scarcely or totally not represented, for instance, in the training set. So we need to find a balanced data partition method. For this purpose, we used a method developed at Scuola Superiore Sant'Anna and based on the use of a self-organizing map. This particular kind of neural network is able to cluster high-dimensional data in a two-dimensional map, preserving the distribution and the topology of original data. This way, Once we created clusters of homogeneous shapes, we pick from each cluster the 70% of them and the 30% of them to be put in the training and validation dataset, respectively. This method is proved to be efficient, creating two similar distributions of the input value for the two sets. The second key step consists in variable selection. The problem is simple. We have too many variables, many of them not related with our target. And in this case, expert personnel cannot support in this choice. A typical situation. So we have to select them for building our data-driven model to improve the model performance and gain knowledge on the phenomenon itself. In this work, we tested one filter approach that exploits the correlation between each variable and the target, and our upper approach that is based on the use of genetic algorithms. The first approach is straightforward and quite standard. The Pearson correlation index with respect to the input value is used to rank the potential input variables and select the best ones. This method in many cases is great because it is easy and fast to apply, but it has a limited power as it only considers the individual linear correlation of each input with the target, neglecting eventual interaction or more complex relationship between them. In this work, in the light of correlation values and of their significance, 13 features were selected, much less than the starting 259. These variables include both process parameters and still characteristics. The second tested approach is based on genetic algorithms that are used to evolve a population of candidate solutions to find the best one. A candidate solution is coded as a binary array where one-valued elements correspond to selected variables, as shown in the picture for 3 different candidates. The idea is that the best performing solution survive through generations and mate to create offspring, so new solutions, preserving their best characteristics, namely the inclusions of variables groups actually related to the target. Candidate solutions are evaluated on the basis of the performance of a model tuned and validated by using the variables they represent. In this case, we consider thus not only the single variable contribution, but also the interaction within groups. You can find much more details on this method in this paper. And finally, we are at the model development, the core. The model is a feed-forward neural network created and trained by using Keras, the high-level framework for deep learning models development. This step was not straightforward because we had to set several hyperparameters that can easily affect the model performance. These hyperparameters include the variable selection approach, the scaling method to preprocess the data, the network architecture in terms of number of layers and neurons for each layer, and a couple of network training parameters such as the batch size and the employed optimizer. Since the amount of data available for training was not so big, we tested all the 96 combinations of hyperparameters to determine the best one. And here are the quantitative achievements of the top 10 models expressed in terms of mean % error with respect to the actual input value for the validation coils. As you can see from the table, the overall performance is satisfactory and quite accurate because the mapping is always lower than 5%. And model seems to be stable, is the column of the error standard deviation. We like it because we have a very small standard deviation of this mapping. Among the variable selection method, the genetic algorithm approach is preferable with respect to correlation-based model, especially with smaller nets, so two layers nets. But generally speaking, none of these configurations drastically outperform the others. Although, among the 96 tested, some of them was not good at all. We can see the simulation results also from a qualitative point of view. How faithful is the prediction with respect to the original profile? Well, nice as well, as the general trend of the input signal is always kept by our best performing model. This is a good starting point for the exploitation of this model online, since these results can be quite helpful for plant operators. What are our final thoughts about this work? The model works well. The signal shape and values are correctly predicted, and it is a key information for the prediction of the final product characteristics in order to be used for real-time tuning of the picking line process parameters. What is next now? We need to improve the model, trying to be able to catch minor fluctuation of the signal. We will do it by using more data, more coils, and more steel grades, steel types, or product types. Then, the outcome of this model could be automatically used to self-tune the pickling line parameters using, for instance, genetic algorithms. That's all. Thank you for your attention. Now it's time for questions. Thank you again.
Thank you very much for this nice video, Marco.
Thank you.
I can start with a comment. We are dealing with a lot of similar things in my group in industrial applications, but what we came up is that often artificial neural networks are not the best choice, even if it's very trendy at the moment to use neural networks and deep learning. We have made very, very good experiences with genetic programming based approaches right for the data modeling stage. Because if there is some, say, natural science background in the system's behavior, which you want to model with a data-based approach, this approach, which gives you nonlinear mathematical expressions, often outperforms neural networks, especially in terms of generalization. And I think for your application, where you have many features and also the challenge to do the subset selection, which you do with the genetic algorithm, this implicit feature selection strategy, which you also get with genetic programming based symbolic regression, could be a very, very well suited approach. If you like, I can send you some material about this.
Of course, because I don't have any background on genetic programming, and it could be interesting to try to use those techniques. But do you need any knowledge on the phenomenon that you are modeling, or it is a really black box model?
You do not need necessarily a priori knowledge, but it's much easier to hybridize knowledge from the domain compared to a neural network. For example, we are testing around with so-called shape constraints at the moment in our developments, where you can give, if you know from the domain, some knowledge in intervals about the partial derivatives concerning to certain variables. You can use this for your search to favor models which fulfill those shape constraints in order to come up with more meaningful models or something like this.
Okay, because in this case, in the case of pickling line, hot strip mill, these are quite complex processes where we don't really have standard models. We don't have equation derivatives. So we only have the experience of the personnel working on the plant. But well, in many cases, it is difficult to extract this knowledge and put it into models.
Yeah,
and
but
then,
in the standard approach of genetic programming, you do not have to take any pre-assumption about the model structures. You just have to, like in the genetic algorithm, provide the building blocks, which are the terminals and non-terminals, the mathematical operators, and the maximum length and depth of the syntax tree, and so.
No,
but it would go too much into detail. But if you like, I can send you something.
Because I've heard about it, but I never have time to try these techniques. But if you think that these apply quite well to this kind of problems, I
could really imagine. And if you are already firm with genetic algorithms, it's only a small step to move to genetic programming.
Yes, I really like genetic algorithms. I developed also some framework for GA with special characteristics. If you see on my Scholar, you will see there are some publications. So it will be really nice. You will see, you have my name, so you have my mail. Send me anything you think it is helpful.
Okay, yeah, will be a pleasure. Sorry for taking so much time, but it's close
okay.
to our research. That's why I'm very interested. Are there any further questions? No, then thanks again.
Okay,
Michael.
Thank you.
And we move on to the last presentation of this session, which will be given by Kirill Sinelchov, sorry for the pronunciation, who's with the simulation team working as a developer. Yeah, already online. Please share your video with us.
Just a second. Hello everyone, my name is Kirill Sinelchov. I'm from Simulation Team Genoa, and I present you one of our ongoing projects related to utilization of machine learning and genetic algorithms to improve retail management, and in particular to address product promotion strategies. Indeed, when we speak about retail or other commercial activities, one of main goals is related exactly to maximization of profit, which is usually done by selling more products and by increasing margin between cost of acquisition and price to the public. Of course, apart from this, it is possible to improve sales by applying proper strategy such as promotion, but also psychological tricks such as specific formats of price or environments in the shop. Indeed, apart from product price and qualities, properties, it is important to consider label, if it is known or not known, where it is positioned in shops, so if it is evident or slightly hidden, if there are some approaches to attract more people, for example, advertisement or different gifts and bonuses. We need to consider also when product is sold. For example, some products are specific to winter or to summer or to some holidays like Easter. Of course, we need to consider general trends such as preference of biological products and actions by competitors. In our case study, the main goal is to improve turnover of product, which is a requirement imposed by the client. In particular, we are allowed to choose different products to put into promotion, choose a week in which it is expected to be promoted, adjust possible discount, as well as position in brochure for promotion. In this case, position doesn't mean exactly the coordinate or size of image, but if it is placed on first page or on last page, if it is a big picture on top of the page or one of numerous small pictures among others. In this work, our main constraint is limitation to promotion of similar or same products on the same week and in adjacent weeks. So we don't promote same product in consequent weeks, and we try to avoid the promotion of two similar products at the same time. The main algorithm which we propose for this activity is following. At the beginning, the decision maker chooses specific category of interest, which could be frozen goods or speeches or other products. Then, at first step, decision maker is allowed to choose some specific products which must be placed in the promotion or must be excluded from promotion in certain weeks. Indeed, often decision maker is limited by some requirements imposed by his or her supervisor, so certain products must be included or omitted. After this, the system estimates sales and composes the offer proposal. When it is complete, the decision maker is allowed to check it, modify it, and rerun the process of brochure proposal generation. Once the user is satisfied by the result, the algorithm finishes and the user obtains a final version of the proposal. Basically, generation of brochure has two iterative steps. One is based on utilization of artificial neural network trained on past sales and historical data, which allows to identify how certain products will perform in certain conditions. Another main block is optimizer based on genetic algorithm, which tries to improve proposal generated by forecasting model and to promote some different and adjusted the promotion strategy. Once optimizer decides that there is no margin for improvement, or if we exceed the maximum number of iterations, the system proposes a strategy which is expected to be the best one. The system is not autonomous, it includes man in the loop. Indeed, as I already told, the user is expected to be able to include or exclude certain products from offer in certain weeks. Of course, when it is done, this condition must be adjusted and applied to the adjacent weeks. For example, if you want to put a specific product in promotion on the second week, we know that in first and third weeks we shouldn't put the same article, so we exclude it. Regarding products placed in offer in the same week, we perform following main controls. First is subcategory of product, which is provided by the user, by the client, in which we can tell if two different products are similar or not. If they are not similar, we put them in promotion the same week, otherwise we can't do it. Of course, we consider also price. Indeed, we can promote two spark wines in the same week if one is very cheap, another is expensive, So they have clients which are completely different. So such condition would be acceptable. In some cases, we don't have all this data and we need to do hypotheses, mostly based on name. So we perform semantic analysis to check if two products are. Which calculates distance between words or phrases. So the two names of products, if they seem to be too similar, I block the inclusion in proposal in the same week. Otherwise, they can be used. In managing the loop approach, one important consideration is that the decision maker must be involved, so we cannot wait for hours until the system produces best result. We prefer to have a near optimal result, but with fast feedback. To estimate precision of the feedback, first we implemented brute force search for the best solution, but even with relatively small categories of products, it requires at least 30 minutes, but also several hours in some cases to find. At the same time, we found that the genetic algorithm requires much less time, but the error and margin of improvement is quite low. Finally, we introduced a stochastic component to genetic algorithm. We extract products with certain distribution laws based on their known performance. And in such case, the near optimal strategy could be generated in a matter of a couple of minutes, which is acceptable for the client. So, in this project, I demonstrated application of machine learning and genetic algorithms to optimization of sales in retail by development of better and more efficient promotion strategy. Indeed, the system supports decision makers in this field by identifying the correlations and providing proposals regarding the most promising sales strategies. Thank you for your attention.
Thank you very well, Kirill, for sharing your nice video with us. Are there any questions? So may I ask for questions? I do have one myself. First of all, I really like those approaches which are coupling machine learning and optimization, which somehow could be seen as examples for prescriptive analytics, which show us how to do. But especially, I would be interested in some more details about the flavor of genetic algorithm you have been using. What was your data structure and the crossover mutation operators? And did you use a standard genetic algorithm or some flavor like a steady state or offspring selection GA or something like this?
Well, first of all, we used the data provided by the client. It was covering several years of statistics and sales data, and we used it to feed the neural network and to train sales forecast models. Regarding the optimization, we started from traditional genetic algorithm, which then we modified because we did actually opposite field from what you mentioned. So we did pre-assumptions on model structure, because in our case we had statistical data about products and how these promotional strategies are composed. So we optimize the generation of chromosomes in the algorithm, so they are already not bad, let's say. And we start already from well-performing population, and then we apply genetic algorithm with mutations and crossovers, traditional one, to obtain the final result.
Okay, I think the details will be in the paper, I expect also. Okay. Galina, please, you raised your hand.
Thank you so much for your very interesting presentation, especially the second part. I have a question. Is a border in the case between operational and strategic management issues in retail case study?
Well, I was mostly focused my attention on part of development, and for me it's kind of a support tool for strategic decision making. So with this tool, the client, which is a big network of shops, generates long-term advertising strategies. Long term, I mean 1 year term, more or less, which then are adjusted based on current situation. So for me, the part of strategy is related to long-term support for decision makers.
But it's more tactic or strategy?
Well, I'm not expert in these things, so I'm not sure.
Because I think that for this case, you need also maybe to limit your application problem, because there is question about this strategy issues in your case, because you also suggested some issues purely operational, but thank you so much, and thank you for your research part of the presentation. Thank you.
Thank you.
Okay, which was already a good conclusion, Galina. Thank you, because the only thing left to me is also to say thank you, especially to the presenters, but to the audience also for actively discussing and stating questions. So have a nice lunch break or whatever time zone you are breaking.
Thank you.
Okay.
Thank you so much. Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.
Okay, have fun from California.